Okay, students, so next is your intervals are subset of set of real number. Now what is this? Intervals. I told you right last time we will discuss about open interval and close interval also. Open interval, this bracket, first bracket, then we will discuss about second bracket also. This also have different meaning in sets. Okay, so don't get confused. When we write sets, we always use curly bracket. So don't get confused between this. I will explain what is this now. Okay, now see here. The topic is intervals as subset, means this will be your set now. Okay, but it will be subset of what? Set of real numbers. Now first let's study what are the different set of numbers we have studied in your lower classes, right? So the different set of numbers which you have studied is set of natural numbers, right? You know what is set of natural number. Then set of whole number also you have studied. What is set of whole numbers? I hope you have understood that also. Then we have studied about integers. Integers is denoted by capital Z. Okay, notation. These are notation for special kind of set, I say, right? Set of natural number. What are the elements here? 1, 2, 3, 4, and it will go on till infinite, right? What are the set of whole numbers? 0, 1, 2, 3, 4. You have to understand the numbers very well. Okay, set of real numbers, student used to get confused, so you need to know what it is exactly. So Z is what? Integer. Set of integers 0, 1, 2. It will go on till infinite. Here on your left, -1, -2, and it will go on till infinite on your left also. Okay, so it is close by this one. So these are the elements here. Next, you have studied set of rational numbers. Now all your integers are your rational numbers, whole number, natural number, all are rational number. Now what was rational number? Any number that can be written in the form P by Q, where Q cannot be 0. Any number that can be written in the form P by Q, where Q is not equal to 0, is your rational number, right? Remember? So in this case, what kind of numbers will be there? Obviously integers will be there, whole numbers, natural numbers also will be there, right? Because every natural number, for example 1, can I write this one in the form P by Q? Yes, of course. P by Q means 1 by 1 I can write. Any number I can write like that. Natural number 3, can I write 3 by 1? So P by Q form, where Q is not 0. So all are rational number. Other than this also, fraction which you have, fractions are also rational numbers. So all those elements will be there. Now in this case, infinite numbers, and exactly you cannot write down the numbers here. Okay, so that's why we have studied roster form as well as set builder form. The one which we cannot list, we can write down in a property form, or you can say in general form, right? So that is your set builder form. So here infinite number of elements will be there like this: 2 by 3, 2 by 4, or 2 by 5. 2 by 4 it will be 1 by 2 only, right? Okay, let me write down 1 by 2, like that. Infinite numbers of element will be there, but exactly you cannot put the position here. Okay, because infinite. In this case, fine, you can write integer 0, 1, 2, 3 like that. I will teach you how to write down this kind of sets. That only we are going to study now. Okay, so anyway, rational number, I hope you have understood. Next, you have studied about irrational numbers, right? After that, you have studied the biggest set of number is, the irrational number was what? Those number which are not rational, that will be your irrational numbers, right? This also you have studied in class 10. So these are the set of numbers. And set of real number, what it is? All kind of number which you have studied in your lower class. All kind of number, natural number, whole number, integers, rational, irrational, all including will give you a set of real number. Okay, so in real number, 1, I cannot put comma. Okay, let me put comma, dot dot dot, then 2, dot dot dot, 3, dot dot dot, like that will come. Here -1, -2, dot dot dot. Why I am putting dot dot dot? The reason is, between 1 and 2 you know infinite numbers are there, and those numbers are your rational numbers, right? And irrational numbers. So all numbers will be there in this case. Dot dot dot, then again -3. So in between these numbers are also infinite. In between 1 and 2, how many numbers are there? Can you tell me? obviously it will be infinite numbers. If you say only 1 by 2, no, I will say more numbers are there. I can say 3 by 2 is also there. 3 by 2. 3 by 2 is how much? 1 point something, right? So that also will be there. 1 point something means what? Between 1 and 2. So in this way, infinite. Between 1 and 2 only I can write down infinite number of infinite numbers I can write down here, right? So like this, 5 by 4, 3 by 2, 6 by 5. In this way, infinite numbers I can write. 7 by 6, 7 by 4 also. In this way, infinite numbers will be there in between 1 and 2 only. Now it is not possible to list all this element in this case. Okay, can you tell me after 1, just after 1, what is the next number? No one can tell you that, because there is infinite number. Just after this, what will be the number? That no one can say, because there are infinite numbers between 1 and 2. And before 2, just before 2, what will be the number? Can you say? Obviously no, you cannot say, but you can write down like this the numbers, right? And you will keep on writing this one without ending, right? So there will be infinite numbers between 1 and 2. Now this is also a collection. Okay, I hope you have understood what is real number. Real number is a collection of all set of numbers which you have studied in your lower class. Now you will study again. This is the biggest set you have studied in your lower class, but this is not the biggest set of number. Okay, you have much more bigger than this. I hope you have understood from here. Comparing all this set of numbers, this is the biggest one, because here you will have natural number also, whole number also, integer also, rational number also, irrational number also you will have here. So in this is the biggest set of numbers. Now in your class 11 you will study bigger than this. Again there is a set, okay, that is complex numbers. Sir Talukdar will explain you that one. That is very simple chapter. So that is the biggest set of number, complex number. Okay, real number is not a bigger set of number. Anyway, mostly we will deal with set of real number only, not complex number. So anyway, this is the biggest set of number till now, right? Now see, in this set itself, I cannot list all the elements. It's impossible to list all the elements here, because infinite elements are there, right? So we used to put dot dot dot. Now this is not the exact representation of sets. Anyway, so I will consider only a part of it. Okay, suppose 1 and 2. Now between 1 and 2 there are many elements again. Now how to write down this collection in set? Now when I will write down set, you cannot write 1, the next element you cannot list it, right? What will be the next element? I don't know. It might be 5 by 3, or it might be 5 by 4, right? Who knows that? So in this way, infinite, it might be 3 by 2 also. It might be 3 by 1 not possible, 3 by 2 or 4 by 3 say. In this way, infinite, I don't know just after 1 what will be the element. So how we will list the element here? So we cannot, it is impossible to list the element in this set. So how we will write down? So instead of writing like this listing form, can we write in set builder form? I want to write the elements here, right? But I'm not able to list all the elements. So what I will do, I will write down this one in the set builder form. So how I will write? I want to write which element, 1 to 2, whatever elements are there, all I want to write in the set. So see how I will write in set builder form. Can I write x? Now what is x? X is a number from 1 to 2. See how I'm saying from 1 to 2. I'm not saying 1, then this. I'm not saying that, because it's not possible to say what will be the just next number after 1 or before 2. So how I will write? Let the set be x. Now what is x? X is a number between 1 and 2. So can I write x is a number less than equal to 2 and greater than equal to 1. When I write like this, did I mention that x is a natural number or whole number? I didn't mention, right? So x, I will write better here. X belongs to, I will write set of real number. When I say x is a set of real number, it will be from this set, you understand? And then I have given restriction. You can see x, I have said less than equal to 2 and greater than equal to 1. So you know, in set of real number, elements will be like this: 1 2 3 dot 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 here, comma comma dot dot dot, then again dot dot dot, next will be 4. It will go on like this. So these are the elements here, infinite elements, 0 minus 1, all elements are there, right? So when I write x belongs to real number, we understand that x will be from here, from this set. Okay, now I have given restriction. What is the restriction? X is less than 2. Less than 2 means what? This element I am excluding now. Less than 2 and then greater than 1. So elements will be from 1 to 2. Then I have said equal to 1 also, equal to 2 also. Means in the set 1 will be there, 2 will be there, and between this whatever elements are there, all will be there, because I have said x is less than equal to 2, greater than equal to 1. But if I would have written x belongs to natural number, set of natural number, then what will be the element? If x is a natural number, then x greater than 1, equal to 1, and less than equal to 2, then the element will be only 1 and 2 if it is a natural number. But I am saying x belongs to set of real number. The moment I've seen that x belongs to set of real number, means x will be from here, from this set, infinite elements. Then again I've given restriction, x less than equal to 2 and greater than equal. So I'm not going to take all the real number. Which one I will take? Only 1 to 2, and 1 and 2 also will be there in the set, because equal to 1 also I have said, equal to 2 also, means x will be 1, x will be 2 also, and x will be less than 2 and greater than 1. Less than 2 means this elements, and greater than 1 means this element. So between these whatever elements are there, all will be there in the set. So I have mentioned the set, and I don't have to list also now. Okay, so this kind of set have a special name now. Okay, so those we are going to discuss. So I hope you have understood what is real number. Okay, in real number, natural number will be there, all natural number, whole number also will be there, integers also will be there, rational numbers also will be there, irrational numbers also will be there. Okay, so that's why this is the biggest set of numbers you have studied in your high school level. Now again I repeat, bigger than this also set is there which you are going to study. Okay, so till now this is the biggest set. In this, all kind of set which you have studied is included here. Okay, so let's try to study different type of set now. So see here, intervals are subset of set of real numbers. Now see, first set is open interval. These are all set, remember. This is set, open interval, special name is given. Now what kind of set is this? So see here, let a comma b belongs to R, means I have taken two elements from R. In use, you know, in set of real number, infinite elements will be there. All the numbers which is there in your number system, all will be there. Okay, like this I will write 0 dot 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 minus 1. I hope you have understood why I am putting dot dot dot, because in between this only infinite elements, in between this only infinite numbers or elements are there. Okay, so see here, I have taken, in general way I have written this one, let a b belongs to R. Suppose 1 and 2 belongs to R, I am taking. Okay, then what it says, n a less than b. So 1 is less than 2 I have taken, right? Obviously all number, when you select some number between this from this set of real number, if you select any two number, obviously one will be less, one will be greater. So just that to mention here, we have written this. Okay, then the set, this one, can you see the set here where the element is x, n? What is x here? X is less than b, greater than a, not equal. I didn't put sign equal. Means what? This will be, open interval will be your set. What kind of set? So see carefully, open interval will be a set. So set always written in curly bracket, right? Now what will be the element here? Element will be, now 1 2 belongs to R, we have taken, right? 1 2 we have taken from set of real number, and 1 is less than 2, you know that. Now it is given here, open interval is a set where the element is x. Now what is x? X is less than b. Less than b means here what is b? 2 greater than 1 means what will be the element here? Obviously it is not possible to list, but still I will show you example. Here the element will be like this. 1 will not be there because x is what? Greater than 1, not equal. So greater means in your set of real number dot 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 here 2 dot dot dot. In your set of real number greater than 1, what are the numbers? Just after 1 you don't know what is the element exactly, right? So element it's not possible to list. So 1 you cannot list it here because it is not equal. X is not equal to 1, right? Equal is not given here, but x is what? Greater than 1 means greater than 1 means after 1 whatever number is there, that will be there in this set. Okay, just after 1 whatever element, if it is 5 by 3 then that element will be there. But you know that before this also number is there. It is not possible to find out what is the next number after 1. Okay, but if you ask me, give me a number, I will give you something. Say, I will say like this, 6 by 5, but you will say no, this is not the number. Before this also you can give one number, right? So see, I am able to say what are the elements. So if you are able to say what are the elements, obviously it is well defined. Why I am saying this is, some student might be thinking that after 1 I am saying that what is the element exactly, you cannot say. So you might be thinking that if it is not well defined, then how can it be set, right? So it is actually well defined because see, I am able to write down the elements here. Okay, what will be the number here I can say exactly, but right after 1 what will be the number, that I cannot say because it's impossible. Infinite numbers are there. Okay, so it is well defined, remember. So it will be a set. So right after 1 whatever element is there, that will be here in this set. I hope you have understood. 1 is not included in this set, remember, 1 is not there. Then what will be the ending element here? Ending element will also be that number which will be just before 2. You can see x is less than 2 but not equal. So if it is not equal, 2 is not included in this set. So what will be the last element here? Just before 2 whatever is there, that will be there in this set, and between that whatever elements are there, all will be there in this set. Okay, so I'm not able to list the element here, but I have written that one in the form of set builder form. So once you see this one, you need to understand what are the elements here. X greater than 1 and less than 2, and x is what? X belongs to real number, right? Set of real number means x greater than 1, there are infinite numbers, so those will be the elements, and less than 2, those will be the elements. So graphically how we used to represent this in your number system, this is 1, suppose this is 2. So what are the elements here? Greater than 1 and less than 2. So this all elements which is there between 1 and 2, all will be the elements, but 1 is not the element, right? So we used to make a circle like this. We used to make circle like this. So this is called open interval. Okay, now in open interval what is the element? From the graph how to know? This dark portion is the element, and since the circle is given here with no shaded region, so when it is not shaded, this circle portion is not shaded, means 1 is not the element there. Okay, and 2 is not the element there, but before 2 whatever is there, that will be the element. Before, after 1 whatever is the element, that will be there in the set. Okay, so that kind of set, it is called open interval. So I hope you have understood why you are not able to list the element, because after 1 what is the element, we don't know exactly. Okay, because infinite numbers will be there. Okay, but what are the elements between 1 and 2? If you say, I can keep on giving you the elements, but it will never end. Okay, I can keep on giving you the elements, I'm saying, means I can write down the elements, what are the here, what are the elements here, I can write, but it will never end. That is the condition. Okay, so that's why it is well defined and it is a set. Okay, because I am able to write down the elements here. Just now I've shown, right? These are the elements. If you ask me, give me 1000 elements here, I can give what are the 1000 elements here. I will write like this: 5 by 3, 5 by 4, or 7 by 4, 7 by 5, 7 by 6, all will lie between 1 and 2 or not. You can see this will be 1 point something, 1 point something, all numbers. So obviously between 1 and 2 these elements lie. So in this way I can give infinite numbers to you. okay, elements here. But right after 1, exactly what is the element I cannot say, so I cannot write this one in roster form. So set builder form is the only option to write down open interval. So this is denoted by like this. This is notation, the one which I have said. We are going to use this bracket. This is notation. Like for example, set of natural number, what is the notation? Capital N we used to denote, right? And elements we used to write like this, 1 2 3 4, like this, right? So this is the notation. So same for open interval, we have notation. We don't show open interval with letter or something like that. We used to write directly like this, 1 comma 2. So when we use this bracket means what? It is a set in which what are the elements between 1 and 2. This 1 is not there in the set, 2 is not there in the set, but after 1 and before 2, whatever is the number, whatever number is there in your set of real number, those will be the elements in this set. Okay, so when it is open bracket like this, try to understand it is a set in which elements are between 1 and 2, but 1 and 2 is not the element there, okay, because I'm not using equal sign here. Okay, so that is your open interval. So this is what all about written here. Okay, so I will suggest better try to understand from the example which I have given. Okay, after that you see all this, otherwise it will be difficult to understand these things. Okay, next, close interval. So close interval, you know, close bracket how you used to give like this. This will be the notation for close interval. So obviously you have understood, I guess, close interval is nothing but your set only. What kind of set? Like for example, again I say it, right? Set of real number 1 2 dot dot dot, element will be there, here also elements. So I have selected 1 and 2 only. Suppose element I want to write between I want to write all this collection 1 to 2, whatever elements are there I want to write in collection. So how you will write down? So when you will write down all the collection of this elements from 1 to 2, from 1 to 2 I said, not between 1 to 2, okay, from 1 to 2 means 1 also I want to keep it in the set. So what will be the element here? X is less than 2, greater than 1. That was open interval, right? 1 was not there in the set, 2 was not. Now I will include this set. So how I will include? Equal. X is equal to 2 also, and X is equal to 1 also, and X belongs to set of real number again. So when I write X belongs to set of real number means X is those elements from the real number. Now what are the restriction? X is less than 2 and equal to 2. So what will be the element here? Your element will be equal to 2 means what? 2 will be there in the set. Now before 2, less than 2 is also there, right? X is less than 2. Less than 2, whatever elements are there, all will be there. But again restriction is there. X is greater than 1. Greater than when 1 means after 1, whatever elements there, those will be there. And it is equal to 1 also. Equal to 1 means 1 also will be the element in this set. So you can see the boundary element also I can, means the last element and the first element also I can give in this set, in this collection, where 1 and 2 is also included, and between this whatever numbers are there, those also will be there in this set. Okay, so this set is called close interval, where 1 is included, 2. So whenever this bracket is there, try to understand this element also there in the set. Here also close bracket is there, right? This element also will be there in this. Between this whatever is there, that will be there in the set. Okay, infinite set. So this also obviously you cannot write in roster form, right? Listing form. So how we can write? Can we write in set builder form? X less than equal to 2, greater than equal to 1. So this is how we write down for X belongs to set of real number. This is the roster set builder form for this close interval here. Okay, so when you have this bracket, understand that elements of this set is included. This one is included, and between this whatever elements are there, all will be there in the set. Okay, but we cannot list, right, infinite elements, so set builder form only we used to write down. Now graphically how we used to show this? 1 2, then in the number system 3 4 5 all this will be there, right? 0. So when I put circle here, understand that the set will be here only, right? Now this is the dark portion, means these are the elements here, means between 1 and 2 all elements will be there. Now this is also there, right, in the set, so we used to shade this region also. Okay, means in your graph whichever is the dark portion, that is your elements there. So this is the graphical representation. You don't need this one, but still it's better to understand right now because they might ask sometime question, right? So it's better to know it. Okay, so this is the graphical representation of closed interval. Okay, so I hope you have understood what is closed interval and what is open interval. This open bracket, whenever is there, whatever is the element here written here like this, then this is not included in the set, this is not included, but between this whatever numbers are there between 1 and 2 all will be there in the set, all. Okay, so it is written like this, less than 2 but greater than 1, and it is not equal to 2. X is not equal to 2 means 2 is not included in the set. Okay, and in this case equal to is there. Okay, so with this I hope next you will easily understand semi-open or closed interval. Semi-open means half open. Half open means it will be like this. If I say this is the set, what will be the element? This is notation, remember, just a notation. Elements we always write down inside curly bracket. Okay, now obviously this time also it is impossible to list the element, infinite elements. In this case we understand that between 1 and 2 whatever elements are there all will be there. Now since here open bracket is there, 1 is not included in the set. Right after 1 whatever is there, that will be the elements here. Okay, all will be there, and the last element you can see closed interval is there means what? Closed bracket is there means this element is included in the set, it is there in the set. So the last element will be 2 here. So between this whatever is there all will be there. Right after 1 whatever number you have, that will be the first element here, then after that all elements till 2 will be there. Okay, so this is the elements in this set. Now obviously this is not the way we represent, right? You have to mention the elements here. So how we will write down this one? X, set builder form we will write. And what is X? X is less than and equal to 2, and it is greater than 1 but not equal to 1. Okay, 1 is not included, just greater than 1 means after 1 whatever is there, that will be the element. Okay, so this is the set. Notation is this one, like we used to put letter, right? In case of set of natural number, N we used to put whole number, W. So in case of intervals we used to put notation like this. So with this only I can understand what will be the elements here. Elements will be greater than 1 and less than equal to 2. Very simple to understand. Okay, so I hope you have understood the example. If you have doubt, just ask me in the comment section. Okay, and don't try to understand all this topic from the definition here. First try to understand whatever example I have given from there. If you have understood, then see the definition, then you will easily understand all these things. Okay, so with this we will start the exercise. And one more thing, graphically how you will represent this one. I hope you have already understood how to represent graphically also. Elements are 1 to 2, but 1 is not included, right? So 1 I will not shade it, 2 is included, 2 I will shade it. So dark region is your set, remember. So between this whatever is your element, all will be there. So this will be the set, graphical representation of this set. Okay, this dark portion. This means what? Right after 1 whatever is the element, all will be there till 2, and 2 is also there. Okay, so this is the graphical representation of this set. So with this we can start our next exercise. Okay, so in the next class we will discuss that. You can try the exercise now.